Okay, so here are some additional examples of evaluating definite integrals using u substitution. So looking at this function, x plus 2 over x squared plus 4x minus 3, we can't integrate using any of the basic integration rules. So we're going to try u substitution. So why don't we let u equal to x squared plus 4x minus 3. So then du over dx will be 2x plus 4. And remember, we want the derivative of u to be able to cancel with whatever is left in terms of x in the function. So if we solve for dx, we'll get du over 2, which I'm going to rewrite this as 2 times x plus 2 by factoring out the 2, equals to dx. So I can rewrite my integral. I'm going to hold off on writing the limits of integration for just a second. Okay, so notice that the original integral, we're integrating on the interval from 1 to 3, where 1 is the lower limit and 3 is the upper limit. Well, this is when we're integrating with respect to x. So because when we do u substitution, we're trying to rewrite the integral in a simpler form so that we can integrate with respect to u, we're going to need to change our lower and upper limits to be in terms of u. So to find my new lower limit, so originally our lower limit in the original integral is 1. I'm going to substitute 1 into what I let u equal to. And when I do that, I end up with 2. So the new lower limit will be 2. And the new upper limit, so I'm substituting 3 into what I let u equal to, will end up being 18. Okay. So we can see that we can actually cancel the x plus 2's. And I'm going to rewrite this as the integral from 2 to 18, and I'm going to leave the 1/2 inside of the integral. You can pull it out, but I prefer to leave it in. If you pull it out, you'll just have to distribute it at the end. Okay, so if we integrate 1/2 times 1 over u, that's going to be 1/2 times ln of absolute value of u. And then now we can just apply fundamental theorem of calculus. So 1/2 ln of 18 minus 1/2 of ln of 2. And if we factor the 1/2 out, right, we'll have ln of 1/2 times ln of 18 minus ln of 2. And that can actually be written as a single logarithm, ln of 18 divided by 2, which is just ln of 9. So this integral is equal to 1/2 times ln of 9. Now the other way to have done this without having to to change the limits of integration would have been to integrate using u substitution still the indefinite integral, and then once you have substituted the x squared plus 4x minus 3 back in for u, you could have then applied fundamental theorem of calculus with the limits of 1 and 3. I preferred this method though. Okay, I'll do 1 or 2 more of these. Switch up the color. Okay, so one option here, this is a polynomial function. One option would be to multiply this out, but that just looks like a pain. So let's let u equal to 2x squared minus 4x plus 1. So du over dx will be 4x minus 4. And dx will be equal to du over, I'm going to write that as 4, factor the 4 out, so 4 times x minus 1. So I can get that x minus 1 that's left to cancel. And then finding my new limits of integration, I'm going to substitute 1 into what I let u equal to find my new lower limit. So that would be -1. And then I'll substitute 2 into what I let u equal to. So that would be +1. So we'll have the integral from -1 to +1 of, we still have that x minus 1 times u squared du over 4 times x minus 1. So the x minus 1's can cancel. And we'll have the integral from -1 to 1 of 1/4 u squared du. Again, up to you if you want to pull the 1/4 out, that's totally fine. You can integrate so that you would have 1/4 times 1/3 u cubed, and then from -1 to 1. You also could have had this 1/4 pulled out front of the integral, where then you have 1/4 outside when you integrate and you get 1/3 u cubed from -1 to 1. So then when you apply fundamental theorem of calculus, it'll be 1/3 times 1 cubed minus 1/3 times -1 cubed. And that'll be 1/3 plus 1/3, which would be 2/3. And that is 1/6. Okay, so why don't we let u equal to 4e to the x plus 1. So du over dx is 4e to the x, 4 times e to the x. You'll have du over 4e to the x is equal to dx. Changing our limits of integration. Okay, so our new lower limit of integration, I'm going to write as 4 over e plus 1, right? That's the same as 4 times e to the negative first power. And then our new upper limit of integration is just 4e plus 1. We still have e to the x there over u, and then the du over 4e to the x. The e to the x's will cancel. So it'll be 1/4 times 1 over u du. We could also pull that 1/4 out front. Or I'll pull the 1/4 out front. Okay, so the 1/4 will hang out there. Integral of 1 over u is ln of absolute value of u. And then fundamental theorem of calculus will have ln 1/4 times the quantity ln of 4e plus 1 minus ln of 4 over e plus 1. And I can get rid of the absolute value bars, because those absolute value bars mean that if we were to substitute in a positive or a negative value, it forces it positive. So since 4e plus 1 and 4 over e plus 1 are both positive values, the absolute value of them is themselves. And I can always rewrite this as a single logarithm, so as 1/4 times ln of 4e plus 1 over 4 over e plus 1. And we're done. I guess we could get rid of the complex fraction by multiplying by e over e in the argument, but this is fine. Okay, last example. Let's let u equal to ln of x. So du over dx is 1 over x. So we have x du equals to dx. Finding our new limits of integration. Ln of 1 is 0. Okay, so we'll have the integral from 0 to ln of 4 u over x, and then x du. So those x's will cancel. And we're just left with the integral from 0 to ln of 4 of u du. Okay, so fundamental theorem of calculus, that'll be 1/2 ln of 4 squared minus 1/2 times 0 squared. So the integral is just equal to 1/2 times ln of 4 squared. Okay, so these are all examples of evaluating definite integrals where you need to use u substitution in order to integrate.